Good afternoon. My name is Reynolds Busha. This is my cell phone number, and that's our website address. I'll also share that information on the WhatsApp groups as well when it comes to our website, how to access our website so that you know exactly what we offer as well. So we are a private institution that offers classes to a couple of different modules as well. And part of the modules that we offer is risk management, which is Rsk4805, 04, and 05 as well. So from a risk management perspective, that's basically what we specialize in. So from the previous class that we did, it was an induction class. I would encourage you to go over the video of the induction class that we did, because it will show you exactly what our schedule is between now until you write your exam, what to expect also between now until you write your exam, how to maneuver our website as well. There's also a section of that video where we also go through how to maneuver the website as well. So which means all that information is basically there. So if you're not able to attend the first class, or you were not able to access the link to the video of the first class that we did, I would encourage you to go over that video, because it's basically showing you a blueprint of exactly what you should expect if we're having classes with us between now until you write your exams in February next year. So today, our agenda, remember, for your curriculum, please ensure that you have a good network connection where you are seated. Please make sure that you have a good network connection where you are seated, because usually if you don't have a good network connection, you also find it difficult as well to hear what I'm saying or even see what will be written on the board as well. So please ensure that you have a good network connection where you are seated, so that you can hear what I say during the presentations as well. So the agenda for the class today is we're going to be going through study unit 1, and note that for Rsk4805, we need to go through 9 study units, and the curriculum changed in the first sitting for this curriculum was in year 2021. So the first sitting for this curriculum was in year 2021. So from year 2020, that's when we started using the new textbook as well. And it's got 9 study units. And from those 9 study units as well, there's going to be different chapters that they also expect you to cover under the different study units as well. So please ensure that as you go through the curriculum, you utilize the study guide as provided by the lecturer as well. Now, looking at study unit 1, the main agenda from study unit 1 is that we need to look at the introduction to market risk. And the introduction to market risk is covered under chapter 1 of the prescribed textbook. So if you check under chapter 1 of the prescribed textbook, we look at the introduction to market risk. And under that section, on the second paragraph, we say the chief risk officer, which is the CRO. So the chief risk officer, as the chief risk officer, it is your job to consider how the new venture fits into the company's portfolio. So what is the correlation of the performance of the new venture with the rest of the company's business? When the rest of the business is experiencing difficulties, will the new venture also provide poor returns? Or will it have the effect of dampening the ups and downs in the rest of the business as well? So that's when we're going to be looking at what are the effect of correlation between the new venture and the existing business as well. Because if the new venture has a correlation coefficient which is closer to -1 as much as possible, the more the correlation coefficient of the new venture is to the correlation coefficient with the existing business as well, the higher the diversification level it is as well. So which means that the more diversified you are, the more you're able to maximize your return for a given level of risk. So in this case, they're saying companies must take risks if they are to survive and prosper. So the risk management function's primary responsibility is to understand the portfolio of risks that the company is currently taking and the risks it plans to take in the future. So it must decide whether the risks are acceptable, and if they are, are not acceptable, what action should be taken? So to understand this better, they give us example 1.1. And on example 1.1, they give us the 1-year return from investing 100,000 in a stock as well. So they give us the probability of those returns, and then they give us the expected returns from those returns as well. So looking at this, we are going to be using this table 1.1 as we go through unit 1.1, which looks at the relationship between risk and versus return for investors as well. So when you look at the section on risk versus return for investors, they say, as all fund managers know, there is a trade-off between risk and return when money is invested. So the greater the risk taken, the higher the return that can be realized. So which means they're basically saying the higher the risk, the higher the expected return. So here they say the trade-off is actually between risk and expected return, not between risk and actual return. Reason why they're saying this is mainly because when you look at the performance of your investment portfolio, the performance of your investment portfolio is not guaranteed because no one knows exactly what is going to happen in the future. So the mere fact that you're taking risk, it means the performance of your investment portfolio is not guaranteed. And because it's not guaranteed, it basically means that your risk is not going to be on day zero, your risk is not going to be collected to, against what? Actual return, because we don't know what the actual return is going to be in the future. So your risk is going to be collected against what? Expected return, to say, so how much risk are we taking in exchange for the expected return that we are seeking to generate from this investment portfolio as well. So here they say, the term expected return sometimes causes confusion. In everyday language, an outcome that is expected is considered highly likely to occur. However, statisticians define the expected value of a variable as its average or mean value. So the expected return is therefore a weighted average of the possible returns, where the weight applied to a particular return equals the probability of the return occurring. So the possible returns and their probabilities can be either estimated from historical data or assessed subjectively as well. So when you look at the relationship between risk and expected return as well, we now need to find out exactly, so how do we calculate the expected return of a single asset, and how do we calculate the risk of a single asset as well? So which means on the first section, we are going to be looking at a single asset. Now, as we look at the single asset, remember we are looking at the relationship between risk and expected return. So the first thing that we need to find out on a single asset is, how do we determine the expected return from a single asset? So the expected return from a single asset is given as the sum of the return from the assets multiplied by the weight of multiplied by the probability of return from those assets as well. So the expected return of a single asset is given as the sum of the return of under the different scenarios multiplied by the probability of return under those given scenarios as well. And this is basically how we're able to determine the expected return of a single asset. Then after determining the expected return of a single asset, we also need to determine the risk of a single asset as well. So to determine the risk of a single asset, our first step is to determine the variance. So from a single asset, the expected return from a single asset, sometimes it's also given as mu. So the expected return of a single asset is represented by mu. So whenever you see the acronym mu, it basically means that you're looking at the average, which is basically the expected return as well. Sometimes the expected return is also represented as the return with the bar on top. So the return with a bar on top, in this case, they're basically talking about the expected return. So if you see this notation, or you see this notation, don't be puzzled. They are all referring to the expected return. So the variance in this case is given as the sum of, for each scenario, the return of the scenario minus your mu to the power of 2 multiplied by the probability of the return. And this is how we're able to determine the variance of the returns. So the variance of the returns is given as the sum of the return from the given scenarios minus your mu multiplied by the probability of the returns. So this is how we're able to determine the variance. Then from the variance, that's when we can go on further and say the standard deviation. The standard deviation is given as the square root of whatever amount we get as the variance there. The square root of that amount gives us the standard deviation. So that's basically how we're able to determine the standard deviation as well. So to understand the relationship between the risk and return of a single asset, we go back to table 1.1. And if you look at table 1.1, remember for table 1.1, they give us that information where they give us the probabilities of the returns, and then they give us the returns as well. And then for the first scenario, they ask us to determine the expected return. So from the given information, they are expecting us to determine the expected return as well. So to find the expected return of this single asset, we're going to say, for the first scenario, we were told that, so for the first scenario, we were told that for the first scenario, the return is a decimal. So we're going to put these values as decimals. So we're going to put these returns as decimal. So for the first scenario, the return was 50% plus 50%. So as a decimal, when you want to put a value as a decimal, if it's a percentage, if you divide it by 100, you get it as a decimal. So if it's 50%, as a decimal, is going to be 0.5. So it's going to be 0.5 multiplied by the probability of the return. It's a bit small. Okay. So for the first return, it's 50%, which is 0.5, multiplied by the probability of this return is given to us as a decimal, which is equals to 0.05. So we're going to multiply this by 0.05. Remember, we are summing up. So which means for each scenario, we multiply the return by its probability of return, but the return has to be put in as a decimal. Then since we are summing up, we're going to be summing up whatever amount we get for all other scenarios as well. For the second scenario, we're given that the return is plus 30%. So as the decimal is 0.3, multiplied by the probability of that return, which is 0.25, plus the next scenario, the return was 10%, which is 0.1, multiplied by the probability, which is 0.4. Is there a question? Please put your microphones on mute, unless if you have a question or you want to participate. Please put your microphones on mute. I think then, sorry?
Let's do some of the ultrasound. We'll do another picture from office. I was happy with the way the opening looked. You know?
Please put your microphones on mute. Please put your microphones on mute. All right. On the next scenario, they tell us that the return was minus 10%. So plus, remember you're summing up. For the next scenario, the return was minus 10%, with minus 0.1 is a decimal, multiplied by the probability of that return, which is 0.25, plus the next scenario, the return was minus 30%, which is minus 0.3, multiplied by the probability which is equals to 0.05. So given this information, can you calculate the expected return? So given this information, can you calculate the expected return?
The answer is 10.
So your answer would be 10%, right? So in this case, we say for the first one, your answer will be
2.5.
so it will be 0.025. Remember, you're putting these values as decimals, right? Please note, for Rsk4805, when you're calculating the expected return and the variance in the standard deviation as well, always put your returns in decimals. There's a reason why we're doing this as well, because there are some calculations where if you don't put your values in decimals, it becomes divergent as well from the actual answer that they expect you to have. And because of this, when you're calculating the expected return in the standard deviation, I know when you're doing your undergrad, you're putting these returns as full values. When you're doing your undergrad, you're putting these values as full returns as full values as well. Please, for Rsk4805, put them as decimals. There's a reason why I'm doing this as well. You will see that when you look at it, especially from a portfolio perspective, if you put full values and you put decimals there, your answers will be very divergent as well from what they expect you to have. So put these values as decimals. So the next one, get 0.075 plus 0.04 plus minus 0.025 plus minus 0.015. And this will give you 0.1. And when you multiply that by 100, that's when you get your expected return being 10%. Are we on the same page? Any questions? Anyone lost?
Aligned for now. Thanks, Renos.
All right. Now, so please take note of what I told you. You need to put the returns as decimals. There's a reason why I'm emphasizing this, especially when you look at from a portfolio perspective as well. You need to put these values as decimals. Then in your final answer, you need to multiply that by 100 to make it a percentage as well. Next, we need to calculate the variance as well. So to calculate the variance, we're going to say would be equal to, remember we said for each scenario, you say the return minus the expected return, whatever amount you get, say to the power of 2, and whatever amount you get there, you multiply by the probability for that scenario as well. Which means for scenario 1, your return was 0.5. Your expected return as a decimal is 0.1. You square that, multiply by the probability of the returns, in this case is 0.05. You move on to the next scenario. Your return is 0.3. Your expected return is 0.1. You multiply that by the probability, which is 0.25. You go on to the next scenario, your return is 0.1 minus the expected return of 0.1. You square that, multiply by the probability of 0.4. The next scenario, your return is minus 0.1. Your expected return is 0.1 squared, multiplied by the probability of 0.25. Plus, next scenario, it's minus 0.3 minus 0.1 squared, multiplied by the probability, which is 0.05. So this is how you are able to deduce the variance. So given this information, how much would you get as your variance? So how much do you get as your variance?
The total is 0.026.
0.036. So for the first one, you must be able to get a figure of 0.008 plus 0.01 plus 0 plus 0.01 plus 0.08. And this will give you 0.036. Are we on the same page? Any questions? Anyone lost? Anyone struggling using their calculator? Anyone struggling using their calculator? So we are all fine. So you get a
Comfortable,
variance.
that's why, yeah.
All right. So you get a variance of 0.036. Now to calculate the standard deviation, you're now going to say the square root of this variance of 0.036 would give us the standard deviation. And how much do you get there?
0.1897.
So you get 0.1897. And if you multiply that by 100 to make it a full percentage, you get how much as your standard deviation?
18.97.
So you get a standard deviation of 18.97%. So for a single asset, this is how you would calculate the expected return of a single asset. And this is how you calculate the volatility of a single asset, which is the standard deviation of the single asset. So your return is 10% and your risk as measured by the standard deviation is 18.97%. So this is how you depict the risk-return relationship. So this is how you depict the risk-return relationship for a single asset. Please note, we are dealing with a single asset. Are we on the same page? Any questions? Anyone lost? So that's what we're covering in the on the first section. That's basically what we're covering in section 1.1. So here we see that the expected return, they give us 0.1, which is 10%. Then when it comes to quantifying risk, there is another method that they also use where they say the expected return, where they say the standard deviation can also be given as the expected amount of the return squared minus the expected return squared, and the square root of that will give you the standard deviation as well. So you can also use this method, but the reason why I gave you this method is mainly because for most of you, when you're doing your undergrad, this is the method that you're familiar with. So the method that I've used on the board there, for most of you, that's the method that you are familiar with when you look at the method that you were using when you did your first year, your second year, and your third year as well. So for continuity's sake, I decided you can use this method if you've been using this method previously, but most students have been using the method that I've indicated on the board as well. So for continuity's sake, you can use the method on the board because at the end of the day, it takes you to the same answer as well. Are we on the same page? Any questions?
Hello, can you assist me in computing the variance? Because I don't get 0.036 when I add 0.08 and 0.01 and 0.01 and 0.08.
So you're getting, are you succeeding in getting 0.08
Yes,
and 0.01?
yes,
And here it's 0,
yes,
and this is 0.01,
yes.
and this is 0.08 as well.
Yes.
So remember here, it's 0.008 over here. And this is 0.08. So there's a difference between this value and that value.
Okay.
Are we on the same page there? Do you see why? So please note that when you're doing the additions there, there's a difference between this value and this value. This value has got 2 zeros, and this value has got 1 zero after the comma. Are we on the same page? Are we on the same page?
Yes, we are, but can you please compute it to get the 0.36? Because when I punch it on my calculator, it doesn't give me 0.036.
What are you getting, Nomusa?
I'm getting 0.108.
Same here.
0.01 plus this 0 plus this 0.01 this. Oh, sorry. It's my mistake. This is supposed to be 0.008. Supposed to be 0.008, yeah. This is supposed to be 0.008. Yeah, it's my mistake. Because if you say minus 0.3 minus 0.1, you square that, multiply by 0.05, you get 0.008. Then if you add those, it gives 0.036. Are we on the same page?
Yes.
All right. Thanks for that. Here, it's supposed to be 0.008. Any questions? So moving on. So now we have looked at calculation of risk and return for a single asset. So on the next section, we look at investment opportunities. And under this, they give us the relationship between alternative risk investments, where they give us the expected return and the standard deviation of these investment opportunities as well. So given this, they are basically saying that when you look at this particular figure, we are basically saying that the return for the portfolio expected return can be given by that, and then the portfolio standard deviation can also be given by that as well. So given this information, they're saying now that we have looked at the risk-return relationship for a single asset, we can also look at the risk-return relationship for a portfolio of assets. But the portfolio of assets that I'm going to be looking at in this case is a portfolio of 2 assets. So where we look at a portfolio of 2 assets, they're basically saying, where we look at a portfolio of 2 assets, they're saying, let's say you have asset 1 and asset 2. So you have asset 1 and asset 2, right? So they are saying, when you are calculating the expected return of the portfolio, so when you're calculating the expected return of the portfolio, which is made up of asset 1 and asset 2, we would say the expected return of the portfolio is given as the sum of the expected return of asset 1 multiplied by the weight of asset 1 plus the expected return of asset 2 multiplied by the weight of asset 2. So this is how we are going to be able to determine the expected return of a 2-asset portfolio. So the expected return of asset 1 multiplied by the weight of asset 1 plus the expected return of asset 2 multiplied by the weight of asset 2. And in this case, this is how we would be able to determine the expected return of a given portfolio. They also say, bear in mind that when you're calculating the expected return of this 2-asset portfolio as well, note that the weight of asset 1 plus weight of asset 2 is equals to 100% of the weight. So weight of asset 1 is a decimal plus weight of asset 2 is a decimal gives you 100%. So as a percentage, weight of asset 1 is a percentage plus weight of asset 2 as a percentage would give you 100% of the weight. Because remember, 100% of the weight because your asset is made up of what? 2 assets, which is asset 1 and asset 2. So given this information as well, it would mean even sometimes if you're not given the weight of asset one, if it's a 2-asset portfolio, you should be able to determine the weight of asset two. So this also means that the weight of asset one, if you make the weight of asset one in the subject of the formula in this case, it would mean is equal to 1. Remember this one, you would take it to the other side of the equation, right? If it's carrying a plus sign, it's going to be carrying a negative sign. So which means your weight of asset one can also be given as the 1 minus the weight of asset two. And at the same time, going back to this original equation, so going back to this original equation as well, if you can also be able to deduce the weight of asset two, because to get the weight of asset two, what do? You take weight of asset one to the other side. If it's carrying a positive sign here, it's going to be carrying a negative sign, which also means the weight of asset two can also be given as 1 minus the weight of asset one, because the sum of the weights should give you 1 as well. So if you're given the weight of one asset in a 2-asset portfolio, if you say 100% minus the weight of the asset that is given on the other portfolio, it basically means that you are able to deduce the weight of the second asset as well. Are we on the same page? Any questions? So if we're asked to calculate the expected return of a 2-asset portfolio, this is how we determine the expected return of the 2-asset portfolio. We can also be asked to calculate the risk of a 2-asset portfolio. Remember, we said the risk of the portfolio is measured using what? Standard deviation as well. So the risk of a 2-asset portfolio as measured by the standard deviation is given as the square root of the weight of asset one squared multiplied by the standard deviation of asset one squared, plus the weight of asset two squared multiplied by the standard deviation of asset two squared, plus 2 multiplied by the correlation coefficient between asset one and two multiplied by the weight of asset. I don't want to present it this way. There's something that I want to prove here. So 2 multiplied by the weight of asset one multiplied by the weight of asset two multiplied by the correlation coefficient between asset one and two multiplied by the standard deviation of asset one multiplied by the standard deviation of asset two. So this is how we're able to determine the standard deviation of a 2-asset portfolio. So the standard deviation of a 2-asset portfolio is given as the weight of asset one squared multiplied by the standard deviation of asset one squared plus the weight of asset two squared multiplied by the standard deviation of asset two squared plus 2 multiplied by the weight of asset one times the weight of asset two times the correlation coefficient between asset one and two multiplied by the standard deviation of asset one multiplied by the standard deviation of asset two. So this is how, so when you find the square root of all this, you get the risk of a 2-asset portfolio. In this case, which is the standard deviation.
Hi, Renus. Just a question from my side. Can you please elaborate on the actual definition of when we speak of the weight in this calculation? What is the exact definition of it? What are we referring to?
We're basically saying how much is it contributing towards the total value of the portfolio? How much is it contributing towards the total value of the portfolio? So as a simple example, right? I just want to use the figures that are going to correlate with okay. Let's say for example, they say you have a 2-asset portfolio made up of asset X, which is worth 70,000, and you also have asset Y, which is 30,000. So this contributes towards the total value of the portfolio being 100,000 there, right? Are we together? So when you want to find the weight, you're basically saying of the total portfolio as a decimal, how much, or as a percentage, how much is asset X contributing towards the total portfolio value?
Okay.
And how much is asset Y contributing towards what? The total portfolio value, either as a decimal or as a percentage, which means in this case, the weight of asset X will be 70,000 of the total portfolio of 100,000, which means in this case, the weight of asset X would be 0.7. And the weight of asset Y will be 30,000 over the total value of the portfolio of 100,000, which gives you 0.3. Which also proves our point as well to say, if you already know that the weight of asset X in a 2-asset portfolio, if you already know that the weight of asset X is 0.7, what does that mean? The weight of asset Y is given as 1 minus the weight of asset X, isn't it? Because in this case, it will be 1 minus 0.7, and this will give us 0.3, which is exactly what we got there as well. So it's proving this relationship as well.
Perfect. Thank you.
Right.
Just a follow-up question from my side, Renos.
Mhm.
So in a business context, would we then use this formula to determine from, in terms of from an asset class investment perspective, which investment will bring or will derive better yield to the organization? Should I repeat the question? Or in what instance would this calculation be relatable in a business context?
Now, let's say, for example, you have 2 investments, investment X and investment Y.
Mm-hmm.
In a simplified assessment, and you have investment X and investment Y, and you want to find out exactly which one is the better investment, right?
Mm-hmm.
You will see that this is where it basically means that you're not looking at it as a portfolio. If you're considering 2 investments to see which one is better, it means we are not longer going to be looking at it from a portfolio perspective, because when you look at it from a portfolio perspective, you're saying you are going to invest them together. But if you're comparing them, it means they're mutually exclusive, which means it's either you choose one or the other. So if that is the case, it means you need to assess them individually as individual assets. Now, when you assess them individually as individual assets, it means you're now going to check to see exactly what is the expected return of asset X, what is the standard deviation of asset X for a single asset. Then you all go on and say, what is the expected return of asset Y, and what is the standard deviation of asset Y for a single asset. Then after that, now, there is something else that you have to take into account. Let me see if that would be relevant from, no, they didn't cover it here. So for chapter 1, for Rsk4805, they don't really cover it here. But when you're comparing the 2 investments, right, it means if the 2 investments have the same expected returns, to see which one is better, you look at their standard deviations. And the one with the lowest standard deviation is the one that would be the better investment, if they are mutually exclusive and you're comparing the 2 investments. Then, if the 2 investments have different expected returns, the ideal measure of risk would be the coefficient of variation. I'm trying to think if the coefficient of variation is covered in Rsk4805. I don't think it would be relevant for you. I'm not sure, I can't remember exactly, but I don't think it would be relevant for you. But the more ideal measure of risk would be the coefficient of variation. When you say your coefficient of variation is equals to your standard deviation over the expected return. So in this case, we are basically saying how much is your risk per unit of return. So if the investments have different expected returns and you're comparing them, you're going to be using the coefficient of variation. And when you use the coefficient of variation, you're basically saying how much is your return per unit of how much is your risk per unit of return. So which means whichever one has a lower coefficient of variation is the one that you're going to be choosing as well. If the two assets are mutually exclusive and you're comparing them, you can choose one or the other. That's how you compare the investments as well. Are we together?
Thanks, yeah.
Yes.
All right, okay. So in this case, we are now saying we're trying to assess the risk and return of a portfolio of two assets. So we're trying to find out exactly, so how do we determine the expected return of this portfolio of two assets? And how do we determine the risk of this portfolio of two assets as well? So to do that calculation, it would mean they give us an example. They give us an example under this section. So under this section, they give us this formula which says your expected return of your portfolio is given as the weight of asset one multiplied by the mu. Remember, we said that the mu is basically the expected return. So it's basically the weight of asset one multiplied by the mu, which is the expected return of asset one, plus the weight of asset two multiplied by the mu, or the expected return of asset two. Then they give us the formula for the standard deviation as well. So what I was trying to emphasize on the formula for the standard deviation as well, before I forget, is that when you look at this particular formula, it's not all the time that they're going to give you the correlation coefficient in calculating the standard deviation of a two asset portfolio. It's not all the time that they give you the correlation coefficient. Sometimes, instead of giving you the correlation coefficient, they will give you the covariance of asset one and two. If they give you the covariance of asset one and two, it means this part of the formula is being replaced by this. Because in actual terms, we're basically saying the covariance of asset one and two is given as the correlation coefficient between asset one and two multiplied by the standard deviation of asset one multiplied by the standard deviation of asset two. So the covariance of asset one and two is given as the correlation coefficient of asset one and two multiplied by the standard deviation of asset one times the standard deviation of asset two. That's why I was emphasizing this particular sequence. Reason being, it means that if they don't give you the correlation coefficient in your question, most likely they'll give you the covariance. So if they give you the covariance, it means this part of the equation has been done for you already. All you have to do is to take this covariance and plug it into this formula as well. Are we together? Any questions? So going back to our example question, they say, suppose mu is 10% per annum for asset one, and the standard deviation for asset one is 16% per annum, while mu for asset two is 15% per annum, and the standard deviation for asset two is equal to 24% per annum. Then they also say, suppose also that the coefficient of correlation between the returns is 0.2. If you give it as if it's given as a percentage, it's what? 20%. So if they give you the correlation coefficient as a percentage, you need to convert that to a value as well, because usually correlation coefficient, we are going to be giving it as a value, mainly because I'm going to discuss it just now. The correlation coefficient varies between -1 and +1 as well. So in most cases, they have to give you that correlation coefficient as a decimal. Then they also say table 1.2 shows the values of mu of the portfolio and the standard deviation of the portfolio for a number of different values of weight of 1 and weight of 2. So the calculations show that by putting part of your money in the first investment and part in the second investment, a wide range of risk return combinations can be achieved. So these are plotted in figure 1.2. So they give us table 1.2, and then this gives us a resulting figure 1.2, but initially they give us table 1.2 that we need to concentrate on for now. So which combination of the different weights? Do you see that in the first scenario, you have 0% weight in asset 1 and 100% weight in asset 2. The second scenario, you have 20% weight in asset 1 and 80% weight in asset 2. The third scenario, you have 40% weight in asset 1 and 60% weight in asset 2. And then 60%, 40%, 80%, 20%, 100%, 0%. So which combination of the weights do you think we should calculate for us to get the resulting mu and standard deviation there? So which combination of the weights should we choose? To demonstrate as an example, which combination of the weights should we choose? Any combination.
Yeah, any combination.
But which one? I'm just asking you to pick one so that you can see that the answers should exactly tally according to our calculation as well.
0.4, weight 1 is 0.4 and weight 2 is 0.6.
0.4 in asset 1 and 0.6 in asset 2. So which is going to be this combination here. Okay. So here, remember we have weight of 0.4 in asset 1 and 0.6 in asset 2, right? Then remember, we have now expected to calculate the expected return of the portfolio and the standard deviation of the portfolio given these given values of the mu's and the standard deviation as well. So which means given this information, it would mean that we're going to say for the expected return of the portfolio, the expected return of the portfolio is going to be equal to, for asset 1, the expected return of asset 1, which is the mu of asset 1, it was given as 10%, which is 0.1, multiplied by the weight of asset 1, which you said is 0.4, right? Remember the expected returns, we're putting them first as decimals. Please take note of this. Plus the expected return of the second asset, which they are giving us is 15%, which is as the decimal is 0.15, multiplied by the weight of the second asset, which is 0.6. So given this information, how much do you get as the expected return of these two asset portfolio? How much do you get?
$0.34.
No. For the first one, you must be able to get a figure of 0.04. And for the second one, you must be able to get a figure of 0.09, which gives you 0.13. And if you multiply that by 100, you get an expected return of 13%. Are we on the same page? Any questions? Anyone lost?
I think I get it now. So I think where I was making my mistakes was I was just calculating the entire string, like, you know.
Which calculator are you using?
So I'm using a normal calculator. Like it's a scientific actually.
Yeah, but which brand?
Not a financial calculator, yeah. So it's not giving me necessarily the exact.
Which brand are you using?
It's a Casio.
Casio. But you should also be able to get the exact answers as well, as long as you make sure that where there's a bracket, you put a bracket, where there's a plus, you put a plus as well. You should be able to get the answers. Usually,
I think it's just my computation when calculating, but I agree with answers because I just did it now, and following your computation method, I'm getting the exact same answer.
Okay.
Yeah.
Please note as well, for those who are using the HP calculator, the rules of BODMAS are very, very important. So for those who are using the HP calculator, the rules of BODMAS are very, very important, because remember with the HP calculator, you are not able to see where you open brackets. You're not able to see where you close brackets as well. So usually the rules of BODMAS are very, very important, which means with BODMAS, you're basically saying brackets of, right? So you solve this bracket, you get your answer. You solve this bracket, you get your answer. Then after that, you say this answer plus this answer gives you that answer. So that's how you do your calculations if you're using the HP calculator. For others who are using the scientific calculators or the sharp calculator, where you're able to see where you open brackets there. If you follow exactly to say, I'm opening brackets, I close brackets here, class, I open brackets there, I close brackets there. If you follow that, you will get the answer as well. But if you're afraid of making mistakes, rather separate your answer into different components as well. If you're afraid that what you're going to make mistakes, because remember, missing one bracket, it means the calculator might not interpret the way the calculation the way you want it to calculate it as well. So for those who are using the HP calculator, if you know that you're going to be struggling with BODMAS, rather get a scientific calculator that you're going to be using for normal calculations. So for those who have an HP calculator and you know that you have issues with BODMAS, because remember, as we go with the chapters, the calculations are going to get more and more and more complicated as well. So as they get more and more complicated, if you are not used to your calculator, or if you make a small mistake on your calculation, it messes up the whole calculation as well. And the unfortunate thing about market risk is that sometimes you find that I remember over the years, I've been having the same complaint where students complain that I'm expected to do so much calculations, but the mark allocation is very small. It's always like that. So expect long calculations for market risk with very small mark allocation as well. And because of that, it basically means that you always have to make sure that you bear in mind that you should avoid making mistakes, because one of the issues that many students have when it comes to the market risk exam, they know the concepts, they know exactly what to put in which formula to use, but where they usually struggle with is calculations. Because remember, one small mistake on your calculation, it messes up everything. So imagine you're doing this long calculation. If you make a small mistake here, what is going to happen? The rest of your answer is going to be wrong. And if the rest of your answer is going to be wrong, it basically means that here you're going to get a 0. Just because of a small mistake that you would have made, because you're not that familiar with your calculator. So my recommendation is, if you know that you're not that good issues of BODMAS, and you're using an HP calculator, rather get a scientific calculator that you're going to be specifically using for these type of calculations. That's one. The second one is, rather get a calculator that you're going to be using now at the beginning, rather than saying in December, January, you start looking for another calculator to use as well. The reason being, you need to be very familiar with your calculator for you to avoid making mistakes as well. So if you start familiarizing yourself with the calculator later on during the year, what is going to happen? You are most likely going to be making mistakes in the exam, which means that you're going to be very puzzled that I knew these concepts, but I ended up failing. Why? Rsk4805, the calculator plays a very big part towards you accumulating marks in the exam. You might know the concepts, but if you're not that familiar with the calculator, you are going to be running into problems as well. So please make sure that you take note of this. Are we together? Any questions? All right. So the expected return of your portfolio, you get it as 13%. Now, for this portfolio as well, we need to calculate the standard deviation of what? These two asset portfolio as well. So which means to calculate the standard deviation, we're going to say is going to be equal to the square root of the weight of the first asset. We said is 40%, so it's 0.4 squared, multiplied by the standard deviation of the first asset, which they give us as 16%. So the standard deviation is going to be 0.16 squared, plus the weight of the second asset, which we say is 60%, so it's 0.6 squared, multiplied by the standard deviation of the second asset, which is given as 24%, so it's 0.24 squared, plus 2 times the weight of the first asset, which is 0.4. Please put your microphones on mute. Multiply by the weight of the second asset, which is 0.6. Please put your microphones on mute. Multiplied by the correlation coefficient between asset 1 and 2, which they gave us as 0.2. Multiplied by the standard deviation of the first asset, which is 0.16. Multiplied by the standard deviation of the second asset, which is 0.24. So given this information, how much would you get as the standard deviation of the asset? How much would you get as your standard deviation?
Comma 4563.
So for the first calculation, you must be able to get a figure of, so please note that normally for the exam, they ask you to round off your calculations to 4 decimal places unless otherwise stated. So normally, when it comes to your calculations in the exam, they ask you to round off your in-between calculations to 4 decimal places and your final answer to 2 decimal places. So please take note of that as well. So for the first calculation, you should be able to get a figure of 0, 0, to 4 decimal places would be 41 plus 0.02 plus 0.00. So you must be able to get a figure of 16.88%. In the textbook, they're getting 16.89% because they're not rounding off their calculations as well. So in the textbook, you will be getting 16.89% because they're not rounding off their calculations to 4 decimal places. But normally in the exam, they will ask you to round off your calculations to 4 decimal places. Hence, I'm just rounding them off to 4 decimal places as well. Because if you look at the exam script, let me just check one of the past papers. So if you look at the question, so if you look at a past paper, what they usually do is under the requirements, they say round all calculations to 4 decimal places with final answer to 2 decimal places unless otherwise stated. So unless they give you another rounding off, they are asking you to round off your calculations to 4 decimal places and then your final answer to 2 decimal places. So that's basically the normal treatment. So that's the normal treatment when it comes to calculations in the exam as well. So the reason why I rounded off my answers to 4 decimal places is mainly because normally in the exam, they would ask you to round off your answers to 4 decimal places, then your final answer to 2 decimal places as well, unless otherwise stated. So you will see that the answer that they have in the textbook is 16.89%. And the reason why it's 16.89% is mainly because in the textbook, they were not rounding off their answers. They were taking the answers exactly as they are. So there's going to be a slight difference in your final answer there. Are we on the same page? Anyone lost on how we're getting the standard deviation of the portfolio being 16.89%? Now that we have measured the expected return and the standard deviation of our 2-asset portfolio, they give us the expected return and the standard deviation of the portfolios under the given different assumptions of the different weights as well. So under the different assumptions of the different weights, they give us this. So which means in this case, we saw that if we put 40% in weight asset 1 and 60% in asset 2, it means we would expect that the expected return will be 13%, and the standard deviation would be 16.89%, although ours was 16.88% because we were rounding off our calculations to 4 decimal places as well. So given this information, they give us the expected return and the standard deviation under the different weights. So they give us the expected return and the standard deviation under the different weights as well to say, if the weight is so much, this is how much the expected return would be. So as an example there, if we go on to, so as an example, remember our expected return was 13% and our standard deviation was 16.89%. Now we want to find out exactly, so what would be the risk return combination for the different assets? So what would be the risk return combination for these 2 assets, given that these 2 asset portfolio, if they are going to be having these different contributing towards this amount of weights towards the overall portfolio? So what would be the different expected return in the standard deviation if we play around with the different weightings that are going to be allocating to asset 1 and asset 2 as well? So if we go to our graph or our figure, where we are putting 40% in asset one and 60% in asset two, where we say that under that scenario, the expected return is 13% and the standard deviation is 16.89. You will see that on the graph, it's going to be somewhere along that line of so on our graph, it will be plotting somewhere roughly there. So our graph is now showing us the different combinations of the expected returns and the standard deviation that we saw resulting from the different portfolio returns as well. So the graph is basically showing us the different expected returns and combination of expected return and the standard deviation under the different scenarios as well. So you will see that the other combination in this case is where we would be finding ourselves somewhere here. I'm not sure of the exact figures. I might be a little bit wrong, and then it might be plotting somewhere there. So these are the different combinations of expected returns and their standard deviations, and they are plotting them on this particular graph as you see on the graph above. So the expected returns and their standard deviations now that we're getting for different weights, they are being plotted on this particular graph, and it's resulting in a graph which is plotting as something like this. So it's starting from this point. So the graph is starting from this point where there's a combination of expected return of 10% and a certain standard deviation there. So these are the corresponding expected returns and the standard deviations. And given these points that are plotting there, we're able to draw this particular graph as well. So this is going to result in a graph which is basically plotting along this line as well. Is there any question on how they came about with this particular figure 1.2? Any questions? So given this information, what do we see there? When you go back to your graph, you will see that on our graph, the expected return of 15% results in us having a standard deviation of 24%. And then they give you these particular combinations as well. So the next thing, remember, we have now drawn this particular graph. As well, right? So remember, we have now drawn this particular graph. So based on this particular graph, we now go on to the next concept, which leads us on to the efficient frontier. So the next concept that we're going to be looking at is going to be looking at the efficient frontier. Now, can we take a 10 minutes break until 3:35? Then after 3:35, we're going to be looking at section 1.2, which looks at the efficient frontier. So can we take a 10 minutes break until 3:35? Then at 3:35, we look at the efficient frontier. All right, can we continue? Are there any questions before we move on to section 1.2? Are there any questions before we move on to section 1.2? So section 1.2 looks at the efficient frontier. So section 1.2 looks at the efficient frontier. Now, when you look at the efficient frontier, I'm going to use a simplified example so that you can be able to understand exactly how they come about with the efficient frontier as well. So by definition, the efficient frontier, they are basically saying, let us now bring third investments into our analysis. The third investment can be combined with any combination of the two investments to produce new risk-return combinations. So this enables us to move forward in the northwest direction of the efficient frontier. We can then add a fourth investment. So this can be combined with the combination of the first three investments to produce yet more investment opportunities. As we continue this process, considering every possible investment portfolio of the available risky investments, we obtain what is known as the efficient frontier. This represents the limit of how far we can move in a northwest direction, and is illustrated in figure 1.3. So figure 1.3 basically illustrates the efficient frontier. So basically, by definition, the efficient frontier is a combination of portfolios which enables the investor to maximize the return for a given level of risk, or which enables the investor to minimize the risk for a given level of return. So a simple way of looking at the efficient frontier is where we can say, if we look at a combination of investment assets, investment portfolios, sorry, remember these are risky portfolios, right? So these are risky investments that we are analyzing. So in analyzing risky investments, we are basically saying, when you look at the efficient frontier, we are looking at it from a perspective where we're saying, if you are given investment X and Y and this investment and this investment as well, right? Let's say you are given investment A, B, C, and D. Let's say you're given investment A, B, C, and D. And then of these investments, they ask you to say, if you're asked to choose between investment A and investment B, which of the two investments would you choose? So if you're asked to choose between investment A and investment B, which of the two investments would you choose? So if you're asked to make a choice between investment A or investment B, which of the two investments would you choose and why?
B.
Why choose B?
Because for the same risk, I'll get an expected return that is higher than of A.
Yes. So which means for the same risk exposure, for the same amount of risk, I'm able to get a higher return compared to investment A, isn't it? And the same applies when you asked to choose between investment D and C. For the same risk exposure, I would choose investment D than investment C, because for the same risk exposure, investment D gives me a higher return for the same risk exposure, isn't it? So that's why we say, when you look at the efficient frontier, you want to be able to maximize the return for a given level of risk. So with the efficient frontier, you want to be able to maximize the return for a given level of risk, which means for a given level of risk, if I'm asked to choose between investment A and B or investment C and D, I would choose investment B, and here I'll choose investment D, because for the same return, I'll be able to get a higher, for the same amount of risk, I'll be able to get a higher return. Then if you're asked to choose between investment C and investment B, which of the two investments would you choose? If I'm asked to choose between investment C and investment B, between these two investments, which of the two investments would I choose and why?
B.
And why?
Because with the same return, B have lesser risk than C.
Yes. So for the same amount of return, I'm exposing myself to less risk for B than C. So I'll choose investment B in this case. So what do we see? When you look at the efficient frontier, we are also saying that you want to be able to minimize risk for a given level of return. So for a given level of return, you want to be able to minimize your risk as well. So which means, given this information, we can say that the efficient frontier roughly would be plotting as something like this. So roughly, with ignoring the other things as well, roughly this is where we would expect that we would be able to draw the efficient frontier. Because with the efficient frontier gives us a portfolio of investments which allows us to be able to maximize the return for a given level of risk, and which also allows us to minimize the risk for a given level of return. So this is how we would come about with an efficient frontier as well. Are we on the same page?
Yes, we are.
Yes.
So that's what they're trying to demonstrate on this particular graph that they're giving us here. So on this particular graph, they're basically trying to demonstrate that on the efficient frontier, the portfolios that you find on the efficient frontier, so the portfolio of risky investments that you find on the efficient frontier are those portfolios which allows you to be able to maximize the return for a given level of risk, and which allows you to be able to minimize the risk for a given level of return as well. Now, we can also be able to improve on the efficient frontier, where we are now considering, remember initially we were only looking at risky investments. Now, what if we also have risk-free investments as well? So what if we also have risk-free investments? How would we plot the efficient frontier which takes into account risk-free investments? So previously, we're basically saying that the type of investment that we're looking at here, it's basically just risky investment, which means your portfolio was just made up of what? Risky investments. But what if you want to incorporate a portfolio which also takes into account what? Risk-free investments as well, right? So which means in this case, this is how we would now be able to have a new efficient frontier, which basically means that this new efficient frontier would enable us to have an even better return for a given level of risk. So this new efficient frontier would allow us to even have a better return for a given level of risk. So when you look at this new efficient frontier, what you need to take note of is that, well, remember we said that we are now incorporating risk-free investments and risky investments as well. So up to from the risk-free rate. Remember, the risk-free rate, you're basically saying that you're earning a return without incurring any risk at all. So which means if you want to find your efficient frontier where you're having risk-free investments, your efficient frontier is now going to move from, we're going to start off from point F to point M. And if you look at point F to point M as well, you will see that this graph is plotting above the efficient frontier for risky investments. So this graph will be plotting above the efficient frontier for risky investments. So which means that if you take into account risk-free investments, you are basically trying to improve the risk-return relationship in your portfolio as well. And for you to be able to do that, they are basically saying from point F to point M, your portfolio is going to be made up of part of your portfolio, a certain weighting of your portfolio is going to be invested in risk-free investments, and a certain portfolio weight of your portfolio is going to be invested in what? Risky investments. So for you to be able to plot above this point up to the optimum level M, so up to point M in this case, if you want your portfolio, your efficient frontier to plot above the efficient frontier for risky investments, it basically means that you would want to have a situation where part of your portfolio is invested in risk-free assets and part of your portfolio is invested in risky assets as well. And this is how you're going to be able to have a portfolio which plots above the graph for the the efficient frontier with the risk-free investments. So which basically means that this becomes the new efficient frontier where you're having a portfolio of what? Risk-free assets and risky assets invested in a given weighting as well. So your expected return of your portfolio in that case is going to be given as this, where they are basically saying at any point, which is point I, which is basically any point up to point M. So point I is any point from the risk-free rate all the way to point M. If you want to plot a graph that is able to give you a return that is plotting on the new efficient frontier, you're going to be investing a certain weighting in risk-free assets and a certain weighting in risky assets as well, which basically means that the expected return of your portfolio at any point up to on point I is going to be given as the expected return of the market portfolio multiplied by the weight of the market portfolio plus the risk-free rate multiplied by the weight of the risk-free asset that you're going to be investing in. And remember, the weight of the risk-free asset is basically 1 minus the weight of the market portfolio. So this will give you the expected return that you're going to be able to achieve if you want efficient frontier to plot above the efficient frontier of risk-free asset up to point M. Are we on the same page? Any questions? Now, above this optimum point M, if you want to enhance your risk-return relationship above which, so that it plots above the efficient frontier of the risky assets. So if you want to enhance your risk-return relationship so that your efficient frontier plots above the efficient frontier of risky assets, they are basically saying you are going to be borrowing at the risk-free rate, and then you invest at the expected return of the portfolio as well. So you're going to be borrowing at the risk-free rate, then you invest at the return that you're going to be able to earn in what? In the market as well. So which means if this is basically point J, so which means point J is basically any point above point M of the, which is the optimum level in this case. So if you want to be able to have an efficient frontier where your return of your portfolio are going to be above those returns that are going to be able to be achieved from a risky assets, it basically means that you're going to be borrowing at the risk rate and then investing that money in the market as well. So which basically means that your expected return of your portfolio will be the expected return that you're going to be able to earn in the market multiplied by the weight of the portfolio that you are going to be investing in the market minus the cost of the borrowings that you're going to be getting at the risk-free rate multiplied by the weight of the assets that you're going to be borrowing at the risk-free rate as well. So this will give you the expected return of the new portfolio, where the efficient frontier is going to be plotting about that, the efficient frontier of the risk-free of the risky assets. So it basically means that you're going to be borrowing. Your cost of investment is going to be the risk-free rate that you're going at which you're. So the assumption here is that you're going to be borrowing or investing. You're going to be able to borrow at the risk-free rate, and then you invest at the market rate as well. So if you're going to be borrowing at the risk-free rate, it basically means that your cost of borrowing is going to be you reducing your expected return of the portfolio. So your cost of borrowing is going to be the risk-free rate multiplied by the weight of your of the amount of money or the funding that you're going to be getting from that risk-free from the risk-free borrowings as well. And this is going to be reducing the so which means that the expected return of the portfolio is going to be increased by the return that you're going to be earning from the market multiplied by the weight of the assets that you're going to be investing in the market as well. So which means your investment return minus your cost of borrowing would give you the expected return of the portfolio. And this is how they're going to be able to find an efficient frontier where your new efficient frontier of the risky asset and the risk-free asset and the risk-free investment, or in this case, the risk-free borrowings, is going to be plotting above that, that of the risky asset, the efficient frontier of the risky asset in that case. So are we on the same page when it comes to the risk-return relationship, when it comes to incorporating risk-free assets in your portfolio? Any questions? Moving on the next section, which is section 1.3, we are now going to be looking at the capital asset pricing model. So with the capital asset pricing model, they say a common procedure is to use historical data and regression analysis to determine a best fit linear relationship between returns from an investment and returns from the market portfolio. So this relationship has the form of the return of the investment is given as the risk-free rate of return, which is denoted as A, plus beta multiplied by the market risk premium, and plus the any error, which is basically a random variable, which is basically an error term as well. So this is basically how we are going to be able to determine the return. So from this reasoning, this is how you're now going to be able to deduce the expected return when you're using the capital asset pricing model. So they go on further and say, two uncertain components to the risk in the investment return are the first one being a component beta multiplied by market return, which is the multiple of the return from the market portfolio. So the multiple of the return of the market portfolio is basically beta multiplied by the market return. And the second one is a component E, which is basically the error term, which is an unrelated to the return from the market portfolio as well. So here they say the first component is referred to as systematic risk. As you see, systematic risk is measured using beta. Then the second component is referred to as non-systematic risk. So which means non-systematic risk in this case is going to be represented by the error term. So consider first the non-systematic risk. If we assume that the E variables or the error variables for different investments are independent of each other, the non-systematic risk is almost completely diversified away in a large portfolio. So an investment should not therefore be concerned about non-systematic risk and should not require an extra return above the risk-free rate for bearing non-systematic risk. So the systematic risk component is that is what should matter to an investor. So which means they're basically saying in short, they're saying when you look at the capital asset pricing model, the assumption is non-systematic risk would have already been diversified away. So the only risk that is relevant is the systematic risk. So to understand where this is coming from, we first look at total risk. So we first look at total risk where we say your total risk is given as your systematic risk plus unsystematic risk. Now, the systematic risk is also referred to as non-diversifiable risk. And the unsystematic risk is also referred to as the diversifiable risk. Total risk is measured using standard deviation. So your total risk is measured using standard deviation. And systematic risk is measured using beta. So systematic risk is measured using beta, which they also put as a B with a tail there at the bottom. Now, represented graphically, we're saying, so representing it graphically, we're saying, when it comes to the breakdown of total risk, so when it comes to the breakdown of total risk, your total risk is broken down into two, where part of the total risk, so part of that total risk is your diversifiable risk. And this component, which remains constant, is the one we refer to as systematic risk. So this gives us, the graph basically gives us the total risk plotted against the number of different securities. So as the number of different securities increase, our portfolio is being diversified, which means your diversifiable risk goes down. So in this case, when your diversifiable risk goes down, it means it goes down up to a level where your diversifiable risk is now going to be equal to 0, which means your proxy for your total risk is going to be the beta. So when your portfolio is fully diversified, as we see here, we are saying that your unsystematic risk is now 0, which means your proxy for your standard deviation is going to be your beta. So the idea behind the beta is that you use beta as a measure of risk under the assumption that your portfolio is fully diversified. When your portfolio is fully diversified, then it basically means that the only remaining risk is the systematic risk measured by the beta. Are we on the same page so far? Any questions? Any questions? Anyone lost? Now, how do we measure this beta? Your beta is more or less like the gradient of the curve. The beta is basically the gradient of the curve. So which means when you look at beta, beta shows you the gradient of the curve, which shows you the expected return of the portfolio to, or the expected return of the assets to, so it basically plots the return of the assets to the return of the market. So it basically plots the return of the asset to the return of the market. So that's basically what beta measures. So beta basically measures the gradient of that curve, which shows you the return of the asset to the return in the market. So your beta is basically your change in Y over change in X. If you still remember, when you did math, when you looked at calculating the gradient of the curve, we say the gradient of the curve is equal to change in Y over change in X. So in this case, what is your change in Y? When you look at the relationship between the asset and the market, is basically your change in the return of the asset divided by the change in the return in the market. And this is how you determine the gradient of the curve. So which means, given this information as well, it basically means that the reason why we are very much interested in this beta is mainly because we are saying that this shows us the gradient of the curve, which shows us this particular relationship between the change in the asset return and the change in the market return. And the reason why we're interested in this beta is mainly because, remember, we're saying that under normal circumstances, we are assuming that the only relevant risk is going to be your systematic risks, because your portfolio is what assumed to be fully diversified. Under normal circumstances, you would want your portfolio to be fully diversified. So if that is the case, it basically means when you now look at the calculation of the expected return according to the capital asset price model. So when you look at the expected return according to the capital asset price model, we're basically saying, according to the capital asset price model, our expected return is given as, so our expected return would be given as, I'm trying to use the exact notation that they have in the textbook. Your expected return is given as the risk-free rate of return plus beta multiplied by the return of the market minus the risk-free rate of return. So this is how we're going to be able to estimate the expected return. So when you take into account the effect of risk, it basically means that the expected return is going to be taken into account beta. So what does that mean? We said beta assumes systematic risk, which means your portfolio is fully diversified, isn't it? So which means this beta is this beta that we're talking about here. That we say that if you do the calculation, the beta is the change in the asset return divided by the change in the market return. Are we on the same page so far? Any questions? So, breaking down this as well, please note, whenever they give you the question on the capital asset pricing model, take note that the difference between the market return and the risk-free rate of return, the difference between these two, we refer to it as the market risk premium. So the difference between the market return and the risk rate of return, we refer to it as the market risk premium. So on your question, if they give you the market risk premium, automatically it means they've already done what's in the bracket for you. All you have to do is multiply it by the beta, and then you add the risk rate to get the expected return. Are we on the same page? Then, if you take into account beta, you have your asset risk premium. Although this is usually a point of contention, because sometimes when you follow the CFA curriculum, sometimes they refer the asset risk premium as the difference between the market return and the risk rate of return as well. So the difference between the market return and the risk rate of return gives you the market risk premium, and this is how you're able to calculate the expected return. So that's basically what they're trying to demonstrate, and when they give us that particular formula there. So where they give us this particular formula there, this is where the particular formula is coming in. And the reason why we discuss the beta is mainly because, remember, we're saying that we are looking at the relationship between return and risk. So if you're looking at the relationship between return and risk, you also need to know exactly why are they using beta and not using the standard deviation. Mainly because they are assuming that when a portfolio is fully diversified, the relevant measure of risk would be beta. Hence, the capital asset pricing model assumes the portfolio is fully diversified, which means the error component in this case is not going to be relevant because the non-systematic risk is not going to be existing. It's zero. Are we on the same page? So, as a potential theory question, take note of this. They say, an investor should not therefore be concerned about non-systematic risk and should not require an extra return above the risk-free rate for bearing non-systematic risk. So that's basically why we're saying that we're removing what the error term. And then they also say, so the systematic risk component is what should matter to an investor. So when you look at the capital asset pricing model, we're basically saying that the risk component that is going to be relevant to the investor in this case is the systematic risk. So when you look at the capital asset pricing model, the relevant risk that should be relevant to the investor should be the systematic risk. So looking at the information that we have, so looking at the information that is given there, it basically means that the different components of the capital asset pricing model formula can also be plotted on the graph. So the different components of the capital asset pricing model formula can also be plotted on a graph as well. So they give us a graph, which is something like this. And then we have a line, which is something like this. Now, looking at this graph, they say, it's going to be this 10 here. Like that. So please note, the risk-free rate of return is the return that you're earning. So this graph shows you the return that you're earning, right? So it's basically showing you the return that you're earning per unit of what? Systematic risk, which is beta in this case, right? So the risk rate of return basically means that you're earning a return without incurring any risk at all. So in this case, where you look at the return on the y-axis and the beta or the risk on the x-axis, it basically means that your risk rate of return basically plots here, because you're basically saying that you are earning from point 0, you are earning a return without any increase in what? In risk. So you're earning a return without any risk that you're going to be exposing yourself to. So that's why we see that the capital asset pricing model, your graph plots from somewhere here going upwards like that. Then the other issue is to earn the market return. To earn the market return, the assumption is that the beta of the market is always equal to 1. Please take note of this. The beta of the market is always assumed to be equal to 1. So the beta of the market is always assumed to be equal to 1. So if the beta of the market is equal to 1, it means this corresponds with the market return. So for you to earn this market return, the risk exposure that you're going to be exposing yourself to is a beta which is equal to 1. Now, to earn this return of the portfolio, so to earn this expected return of the asset, to earn the expected return of the asset, it basically means that this is where you find that this graph, so any point along this graph, this is how you're going to be able to earn the expected return of the asset as well. So your expected return in this case is going to be corresponding with a certain beta there, depending on exactly how much beta you're going to be exposing yourself to as well. So which means to find yourself along this line, it basically means that your expected return should be equal to your risk-free rate of return plus beta market return minus risk-free rate of return. So whenever you want to find yourself along this line, plotting above the risk-free rate of return, it basically means that to find yourself along this line, it basically means that you are going to say your expected return that you're going to be earning here is equal to the risk rate of return plus the beta of the risk exposure that you're exposing yourself to multiplied by the market return minus risk of return, which is basically based on the capital asset pricing model. Are we on the same page? Any questions? Anyone lost? The reason why I'm breaking this down so that you fully understand these concepts is mainly because when you look at the trend of the exams in 2021, 2022, and even the January 2023 as well, the lecturer loves to bring questions from chapter 1. The lecturer loves to bring questions from chapter 1. And what does he do? He brings questions from chapter 1, but he tries to confuse students by playing around with these different concepts to confuse students as well. So to confuse students, the lecturer brings questions from chapter 1, but what does he do? He checks your understanding of where these different components fit in the capital asset pricing model. So once you understand where all these different components fit into the capital asset pricing model, no matter which way they bring the question, you always get it right. Even if they don't give you the beta, you know how to get the beta. And you know what is the assumption of the capital asset pricing model and why we're using the beta as well. Are we on the same page? Any questions? Anyone lost? All right. So to understand this better, they give us an example. They give us example 1.1. Can you quickly read through example 1.1 and we go through it together? Before we look at example 1.1 together, there's something else I need to explain when it comes to the beta as well. So there's something else I need to highlight when it comes to the beta as well. So remember we said the beta, oh, sorry. So before we look at example 1.1, there's something else I need to explain when it comes to the beta as well, which is, remember we said the beta basically measures the gradient. And it measures the gradient of the change in y, and we know that the gradient of a curve is given as change in y over change in x. And we said when you look at the relationship between the asset return and the market return, it basically means that the beta can be given as your change in the asset return divided by the change in what? In the market return as well. So this also means that the beta can also be given as your systematic risk of your security I divided by the market risk. So your beta can also be given as your systematic risk of the market, sorry, the systematic risk of the asset divided by the market risk. So this is how you're also able to deduce the beta as well. Another way of calculating the beta is where we say the beta can also be given as the covariance between the asset and the market divided by the variance of the market. Remember, the variance of the market is basically the standard deviation of the market squared. So the beta can be given as well as the covariance of the asset in the market divided by the variance of the market as well. The variance of the market is going to be, remember the standard deviation to the power of 2 gives you, like what we saw previously. If you look at it, if you reverse that calculation of from variance to standard deviation, remember we said the square root of the variance gives you the standard deviation, which also means that the standard deviation to the power of 2 gives you the variance. So the variance of the market gives you the standard deviation of the market squared. So which basically means that the beta can also be given as the covariance of the asset in the market divided by the standard deviation of the market to the power of 2. And this can also be given as, we know that we also know that the covariance of asset 1 and 2, remember we said the covariance of asset 1 and 2 can be given as the correlation coefficient between asset 1 and 2 multiplied by the standard deviation of asset 1 multiplied by the standard deviation of asset 2. Which also means the covariance of the asset I and the market can be given as the correlation coefficient between the asset and the market multiplied by the standard deviation of the asset multiplied by the standard deviation of the market. So the covariance of the asset and the market can also be given as the correlation coefficient between the asset and the market multiplied by the standard deviation of the asset multiplied by the standard deviation of the market. So if that is the case, it also means that when we are given the covariance of the asset in the market, what are we going to do? It also means that this can also be given as the correlation coefficient between the asset in the market multiplied by the standard deviation of the asset multiplied by the standard deviation of the market divided by the standard deviation of the market squared. So this would also give us the beta. Are we on the same page? Any questions? Now, to simplify this, so that I'm trying to give you all these different scenarios so that no matter how the lecturer tries to confuse you, you are never going to get lost. So no matter how the lecturer tries to, because The lecturer loves to bring questions based on this section. But for him to be able to bring in new questions, they have to find new ways of confusing students. So we need to make sure that you are always going to be covered from any angle that the lecturer tries to ask you the question as well. So in simple terms, we see that the correlation coefficient of the asset in the market multiplied by the standard deviation of the asset multiplied by the standard deviation of the market can also be divided by the standard deviation of the market squared is the same as saying the standard deviation of the market multiplied by the standard deviation of the market. It's the same thing. So the standard deviation of the market squared is the same as the standard deviation of the market multiplied by the standard deviation of the market. So which means in this case, the standard deviation of the market on the denominator can cancel out the standard deviation of the market on the numerator, which also means the beta can also be given as the correlation coefficient of the asset in the market multiplied by the standard deviation of the asset divided by the standard deviation of the market. So that's another way of determining the beta. So I'm showing you this chain link so that no matter which way the lecturer tries to bring this, you are covered. No matter how they try to confuse you, you know you are covered as well. Any questions? I know it's a mouthful that I've given you today, but we need to be systematic on where we end the class as well. So we're going to look at example 1.1, then we'll look at the assumptions, and then we also look at the alpha, then we know that we're done. So that we know that we've done sections 1.1 to 1.3. So we're just going to look at the effects of alpha. We look at the example, we look at alpha, and then we're done for today. Any questions on the breakdown of the beta, where it's coming from, and how it fits in the capital asset pricing model? Are there any questions? All right, let's go on and look at example 1.1. Can we quickly go through example 1.1 and then we'll go through it together? So, looking at the capital asset pricing model, remember we said with the capital asset pricing model, your expected return is given as the risk rate of return plus beta, market return minus risk rate of return. So, looking at the example, they tell us that your risk rate is 5%, your market return is 10%, the return on the market portfolio is 10%, and then they say an investment with a beta of 0, how much expected return should it have? Then they also give us another scenario where the investment is a beta of 0.5, and then we see exactly how much should be the expected return as well. So which means in that case, looking at the first scenario, if the beta is equals to 0, it means your expected return is going to be equal to the risk rate of return as a decimal of 0.05 plus the beta of 0, market return of 10%, which is 0.1, minus 0.05. So given this information, how much would you get as your expected return? How much would you get?
0.05.
So you get 0.05 multiplied by 100, which gives you 5% return. Remember, there's a 0 here, isn't it? And the 0 is multiplying the bracket. Any number times 0 is 0, isn't it? Automatically, you go back to this. Then, if your beta is equal to the second scenario, they're giving us the beta of 0.5. So if your beta is equal to 0.5, it would mean your expected return in this case is going to be 0.05 plus a beta of 0.5 multiplied by 0.1 minus 0.05. So given this information, how much would be your expected return?
It's 0.075.
So you get a figure of 0.075 multiplied by 100, which gives you 7.5%. And if your beta is equal to, they give us another scenario where the beta is equal to 1.2. And if your beta is equal to 1.2, your expected return would be equal to 0.05 plus 1.2 in brackets 0.1 minus 0.05. And how much do you get?
Zero 0.11.
So it's 0.11, multiply that by 100, you get 11%. So your expected return in this case will be 11%. Are we on the same page? Any questions? Anyone lost? Of interest, what do we see? Out of interest, do you see that the more your beta is increasing, your expected return is also increasing as well, which goes back to the same economic principle that we stated before. The higher the risk the investor is taking, the higher the expected return. So the higher the risk the investor is taking, the higher the expected return. As you can see, when the beta is increasing, which measures systematic risk, your expected return is also increasing as well. Are we on the same page? Any questions? So below this example, they also restate the point that we've already discussed before, where they say the parameter beta is equals to your correlation coefficient multiplied by the standard deviation of the asset divided by the standard deviation of the portfolio, where P is the correlation between the 10 on the investment, the 10 on the market portfolio, and Q. This beta is basically the standard deviation of the 10 on the investment, and this is the standard deviation of the 10 on the market portfolio as well, which is already what we've discussed previously. So when it comes to the assumptions of the capital asset pricing model, please take note of them because they can potentially ask you as theory questions as well. So under the assumption, they say the reason why the analysis leads to conclusions that do not correspond with the realities of markets is that in presenting the arguments, we implicitly made a number of assumptions. And in particular, the first one being, we assume that the investor care only about expected return and the standard deviation of return of their portfolio. And the second assumption is we assume that the error variable for different investments in equation 1.3 are independent. And the third one is we assume that investors focus on returns over just one period, and the length of this period is the same for all investors. Then the fourth one is we assume that investors can borrow and lend at the same risk-free rate. So this is approximately true in normal market conditions for a large financial institution that has a good credit rating. But it is not exactly true for such a financial institution, this is not exactly true for such a financial institution, and not all are true for small investors as well. Then we also, the other assumption is that we did not consider tax. And the sixth assumption is we assume that all investors make same estimates of expected returns, standard deviation of returns, and correlations between the returns for available investments. So this, to put this in another way, we assume that the investors have homogeneous expectations, which basically means that they have what? They have the same expectations in that case. Are we on the same page? Any questions? On the next section, we look at the concept of alpha. So when we look at the concept of alpha, we're basically looking at excess returns. So when we look at the concept of alpha, we are basically looking at excess returns. So when we look at excess returns, we are basically saying when the return of your portfolio is higher than the expected return, we are basically saying that you are expecting to generate an alpha return. So which means in this case, this is what they are demonstrating when we look at this relationship where you compare the return of the portfolio against the expected return as well. So which means in this case, the alpha is basically the difference between the return of the portfolio and the expected return according to the capital asset price model. So which basically means that, to put it in another way, we are saying, remember we said the expected return of the portfolio is given as this according to the capital asset price model. So your alpha basically looks at the relationship between, so your alpha is the difference between the actual return of the portfolio against the expected return. So your alpha looks at the relationship between the difference between the return of the portfolio and the expected return, which means if you expand this, we are also saying your alpha is equal to the return of the portfolio. So we're saying your alpha is equal to the return of the portfolio minus the risk rate of return plus beta, market return minus risk-free rate of return. Which also means that if you expand this bracket, this would be your alpha would be the return of the portfolio. Remember your coefficient is -1, isn't it? -1 times RF gives you minus RF. -1 times beta gives you minus beta, which multiplied by market return minus risk-free rate of return, which basically means that your alpha can now be further simplified into this particular common equation as well. And this is how you're going to be able to calculate your alpha. So your alpha is basically the excess of the returns between the return of the portfolio and the expected return. So which means when your portfolio manager has a positive alpha, so when your alpha is positive, it means the return of the portfolio is greater than the expected return. But your alpha can also be negative. So your alpha can also be negative. And when your alpha is negative, it basically means the return of the portfolio is less than the expected return. So the reason why we're interested in the calculation of alpha is mainly because we use alpha to assess the performance of the portfolio manager. The aim of the portfolio manager is to have an alpha which is greater than what the expected return. It basically means that you're saying that your investment is basically performing better than the expected return. Please put your microphones on mute. So that's why you see where they discuss the concept of alpha, they say, where they discuss the concept of alpha, they say the portfolio manager has produced a superior return for the amount of systematic risk being taken. So the extra return is given by this formula. So this is commonly referred to as alpha created by the portfolio manager. And remember why they said your alpha can be positive or it can be negative, but your ultimate aim is for the portfolio manager to have an alpha which is positive, where the return of the portfolio is greater than what the expected return as well. So to understand this better, they give us example 1.3. Can you quickly go through example 1.3 and we go through together? So for example 1.3, they say a portfolio manager has a portfolio with a beta of 0.8, a risk rate of 5%, a market return of 7%, and the portfolio manager's return is 9%. And then they ask you to determine the alpha of the portfolio. So to determine the alpha of the portfolio, we're going to say the alpha of the portfolio would be equal to, so the alpha of the portfolio would be equal to the return of the portfolio, which is as a decimal is 0.09, 9% as a decimal is 0.09, minus the risk-free rate of return, which is given as 5%, minus the beta, which is 0.8, multiplied by the market return, which is 7%, minus the risk rate of return of 0.05. So given this information, how much do we calculate and get as the alpha of the portfolio? How much would we get as the alpha of the portfolio?
Zero point zero two four.
So you get a figure of 0.024. Multiplied by 100, you get 2.4%. So your alpha in this case is 2.4%. And when your alpha is 2.4% and it's positive, if your alpha is positive, if you get a positive value here, it means the portfolio manager has managed to beat the expected return by 2.4%. So the portfolio manager has managed to beat the expected return by 2.4%. Hence, they're producing what? A positive alpha. Are we on the same page? Any questions? Anyone lost? All right. So if there are no questions, this is where we're going to end. Yes?
Yeah, no. Can you please repeat the steps on how you got to 0.024?
All right. Remember here, we are not using this formula. We're using the further breakdown of the formula, which is this one, right? And based on this, they give us that the return of the portfolio was 9%, and as a decimal is 0.09. The risk rate of return was 5%, as a decimal is 0.05, minus the beta, which is 0.8. Remember, multiply by the market return, which is they give us a 7%, which is 0.07, and the risk rate of return is what? 0.05. When you are doing this calculation, if you're using the HP calculator, follow the rules of board mass. Solve what's in the bracket first, multiply, then you say this minus the answer, you get your final answer. Then if you're using other scientific calculators, you are able to just put everything all at once and get the answer, as long as you make sure that where there's a bracket, you're putting a bracket. Where there's a minus, you're putting a minus. If you're able to do that, you'll never go wrong. So are we all getting 2.4%? Anyone lost? So remember, when we did this calculation, we were no longer using this first formula for calculating alpha. We're using the broken down formula, which was basically the expanded form version of the formula in this case. Any questions? Are there any questions? Anyone lost? All right. If there are no questions, this is where we end today. In the next class, we are going to be starting on from section 1.4. Then after that, we move on to the next. We finish the rest of chapter 1. Then after chapter 1, we move on to the next study unit. Please note that for the month of March until the 31st of March, we are giving free access to our website. And for you to be able to access the material on our website, where we are giving, it basically means that you're going to be able to get the soft copy of the textbook. You'll be able to get the access to the videos as well. Because I think for Rsk4805, I stand to be corrected. I think we managed, we gave access to study unit 1 and study unit 2. I'm not sure about study unit 3, I will need to cross check, but I think we did give access to study unit 1 and 2. Study unit 3, I'm not sure, but I think we gave you access to study unit 3, but I stand to be corrected as well. So this is the material that you basically need, so that at least when you're preparing for the coming classes, you can use that material to prepare for the coming classes as well. Because remember, you understand that with Rsk4805, there's quite a lot of calculations that needs to be done. There's quite a lot of material that you need to consume. So you benefit more when you ask questions in the class. So you benefit more with especially Rsk4805. You benefit more when you ask questions in the class. I always try to give room for students to ask questions in the class, because that's how you're able to see where you're making mistakes and to correct yourself. Once you make that mistake and you correct yourself, you will see that you are not going to be struggling when it comes to the exams. So you won't struggle when it comes to preparing for the exams when you do revision, because which basically means that for you to be able to study in advance, I would advise you to utilize the videos. Because remember, we give you access to videos that we recorded from last year, so that you can use these videos to prepare for the coming classes. So for you to make sure that you are prepared for the coming classes, I would advise you to create a user account, get access to the videos, be able to download the textbook as well, go through these videos in advance as well, so that you know that, okay, fine, in the next class, we're going to be going on from unit 1.4 until the rest of study unit 1, and then we're going to be moving on to study unit 2. So instead of waiting for the class, for next class as well, rather go through the videos, going through the rest of study unit 1, study unit 2. If you do that, you will see that when you're going through these videos by yourself, you highlight things that you're struggling, or you highlight concepts that you're struggling to grasp as well. Then when you attend the class, it's more like you are doing something for the second time. And where you are struggling to get or to grasp the concept, you ask questions. You realize that if you learn, or if you go through the curriculum like that, you will see that you are not going to struggle to understand the concepts for Rsk4805. And you'll see that during the revision period, you're not going to be feeling so much pressure and getting overwhelmed by these exam preparations as well. So I'd advise you to try as much as possible to use the videos from last year so that you're able to use them to prepare for the coming class. Reason being, highlight those things that you're struggling with. When you go into class, you are now going to be knowing that, okay, fine, I didn't understand this, I didn't understand that. As we go through it and you still didn't understand, you ask questions. You will see that it's going to be clear, or the path is going to be clear for you to be able to pass this module. Like I said, many students who go through Rsk4805, the reason why they struggle is usually the issue of the calculator, and it's usually because they have not been attending classes systematically. They have not been catching up on the classes as well through the videos. So what happens, they try to compress all that when they get to December. And what happens, they get so overwhelmed, they start making mistakes in their calculations, they end up failing the exam. So Rsk4805 is more like math. You need to make sure that you give yourself enough time to keep practicing. The more you keep practicing and you go through the videos of the coming classes, you will see that you're not going to struggle with this module as well. All right, if there are no questions, enjoy the rest of your weekend. Those who want to be able to access the videos of the coming classes as well, please send me a direct message. I'll make sure that by Monday, I would have responded to your queries as well. All right, enjoy your weekend.
Thank you.
Thank you, Paul.